Okay, today we're going to talk about rate of change. We're going to calculate the rate of change of a linear function represented tabularly, that means from a table, graphically from a graph, or algebraically in context with mathematical and real-world problems. So we're going to be given a word problem, and then we're going to have to use the representation they give us to determine our rate of change. This is going to be a nice transition into slope, which we are going to learn about in our next lesson. So rate of change, what is it? It's a ratio of the change of the dependent variable to the change of the independent variable. So we've got change in y over or divided by the change in x. And so change, that triangle, is the Greek letter delta, and it represents the word change in. So I don't say delta y over delta x. You would say change in y over change in x. And if you're finding the change in something, two numbers, you're going to want to subtract. So we will be using subtraction. Now, your rate of change can be constant or variable. Constant means that your rate of change is going to be the same. It doesn't matter what two y values and two x values you pick. And in your graph, you're going to have a linear function, which means it's a line. We are going to spend most of our time this year talking about linear functions, so our rate of change, no matter what two x values and y values we use, should be the same. Now, rate of change can also be variable, and that means your rate of change is not the same. That means you're going to end up with a nonlinear function, which means your graph is curved. And we're not going to be calculating the rate of change. We're just going to have to recognize that the rate of change is not the same, that it is variable, and that is it. So let's get into some examples. The first thing we have is calculating the rate of change from a table. So I have a table of delivery service fees, miles traveled, and charges. So what I need to do is I need to be able to know what my x and my y values are. So remember, your x values are going to be in the left column always, and your y values are going to be in the right column. So we're going to set it up. We've got change in y over the change in x. So now I need to go find my change in y first. So I'm going to look at from 14 to 21. What is that change? And it's a change of $7, and it is a positive $7 because I'm going up. From 14 to 21, I have to go up. My next rate of change would be 21 to $28, and again, that is another change of 7, but it is the change of 7 in the positive direction. And then we go from $28 to $35. Again, a change of 7, and it is positive because it goes in the up direction. So our change in y every time in this table was 7, which is nice because now I could predict the next charge in my table. I would know, since the pattern shows me going up 7, I could go up 7 more, and my next charge should be $42. All right, change in x. So from 1 to 2, we go up 1. That's pretty simple. Now, the next change in x is 2 to 3 miles, which is also a change of 1 in the positive direction. We're adding 1 to get from 2 to 3. And then 3 to 4. Again, another change of 1, and we are adding 1. So our change in x for the table is a change of 1. And so now, since it's a ratio, I want to perform that division. So 7 divided by 1 is going to be a rate of change of 7. So our rate of change is 7, and you can see that every time it was 7 over 1, 7 over 1, 7 over 1. So we would say that this rate of change is constant. All right, let's look at this word problem. It says the per capita income of the rural population in Mississippi increased from $22,657 in 2004 to $22,983 in 2005. Calculate the rate of change. So I made this little outline of a table so that we could put our values in. So we've got to put x and y, and we've got to identify what numbers, what values and quantities would go into the x column. So that would be the time. So this is referring to the years. So we've got 2005 and 2004. And then this is going to be, has to do with the money, but remember, you don't just want to say money, you want to identify what is that money actually talking about. And in this example, we are talking about income. So I want to note that this money means income. It's not cost, it's not profit, it's income. And so now I'm going to match it up. In 2005, the income was $22,983. And in 2004, it was $22,657. Okay, so now we want to find the change in Y. But let me get set up first. So change in Y divided by the change in X for this table. Okay, so now let's look at our change in Y. We started at $22,983, and then the next year, in 2004, we had an income of $22,657. So I want to find out what that change is. So all you're doing is subtracting. So take away 22,983 minus 22,657, and you should get a change of $326. Now I want to make sure the sign of my change is correct. I started at a higher income and went to a lower income, which means that is a change of a positive $326. Okay, now if I would have had it switched, if 2004 would have been on the top line in 2005, going from a lower to a higher, actually this should be negative. We went down, didn't we? If we would have had 22,657 first and then we went up, it would be positive. So this really is negative. Almost missed that sign there. It's important. All right, let's look at the years. We started at 2005 and we went to 2004. So we've got to look at that change. That change is a change of 1, but did we add 1 or subtract 1 to go from 2005 to 2004? We actually subtracted 1. So our change in X is also negative. Now, your changes in X or Y can be negative. It's when you perform that division of your ratio where you could end up with a positive or a negative rate of change. So now I'm going to take negative 326 divided by negative 1, and I get a positive 326. Now, I cannot say if this is a variable or a constant rate of change because we only had one rate of change to calculate. So we are not going to state if this is constant or variable because we don't have enough information in this word problem to help us figure this out. Okay, on to the back. Rate of change. So we are calculating rate of change now from a table. And I like to use change in Y over change in X. And if you have a graph, you want to make a table. I don't want to worry about scales and counting rise over run, so I want to keep it consistent. We are going to use change in Y over change in X, and I'm just going to pull some X and Y values off of the graph. Now when you pull Y values off the graph line, you want to make sure that you select X and Y values that you can read very easily from the table. I chose these two ordered pairs because I can easily see that this is an X value of 2 and this is a Y value of 3. So I have 2, 3. And then for my next point, I can easily see that as an X value of 4. And this is a Y value of 5. So I've used the ordered pairs 2, 3, and 4, 5. And now I'm going to find my change in Y over change in X for my graph line. Again, I'm going to start with my Y's because change in Y comes first. So I started at 3 and I went to 5. That is a change of 2. And I am adding 2 to get to 3, from 3 to 5. Change in X. I started at 2 and went to 4. That is another change of 2, and it is also in the positive direction. So my change in X is positive 2. And now I'm going to perform that division. So 2 divided by 2 is going to give me a rate of change of 1. And you can see that because you have a line, this is linear. And if you have a linear function, you know that your rate of change is constant. All right, let's look here. So I've got workers' earnings. We're talking about time and amount, and you can see from the graph line that you have a linear function, which means that your rate of change is going to be constant. Okay. So we're going to do the same exact thing. We are going to make a table of values, table of X and Y values to find our change in Y over change in X. And now I want to point out something. On graph lines, sometimes they try to make it easy for you. So if you pass through the origin, 0, 0, you definitely want to use that as one of your ordered pairs. Make it easy on yourself. Also, too, if they pick out an ordered pair, if you see at the very end of this graph line, they had a point picked out. If they have points already drawn on the graph line, use those ordered pairs. They're like clues. They're trying to help you out. And I can easily see that this graph, this point, has an x value of 40 and a y value of 320. 40, 320. So I'm going to use those points to help myself out when figuring out my change in y over change in x. So I can easily see any change from 0, which is why I'm encouraging you to use the origin if it's a point. I go from 0 to 320. That is a change of 320, and I'm adding. So I know my change in y is a positive 320 degrees. 20. Change in x. I start at 0 and I go to 40. Again, changing from 0, finding that change is very simple. So 40, and we are adding 40. So now I'm just going to perform that division. 320 divided by 40 is going to give me a rate of change of 8. Now I'm sure there were other points you could have used, but those two were the easiest for me to read, and when I'm picking points, I want to choose points that make it easy for me to read the x and y values. Okay, let's look at the next example. So we've got Eve is keeping a record of the number of lawns she has mowed and the money she has earned. Tell whether the rates of change are constant or a variable. So we've got a table, and now it's horizontal, so I need to identify what my x and y values are. Remember, x is the top row, and y is going to be the bottom row if your table is horizontal. And so what they want me to do is they want me to identify the inputs. And when they're asking to determine the inputs, they're not talking about domain and range. They're asking what is the name of the x values. So when we look at x, what are we counting or measuring? And we are counting the number of lawns. We do not measure the number of lawns, we count them, which means that my outputs are now going to be the amount earned, the money. And again, I'm not just going to put money here, I'm going to tell what that money specifically is, because money could be referring to lots of things. And this is specifically talking about the amount that Eve earns. All right, so now we want to find the rates of change. Change in y over change in x. Let me go ahead and draw those real quick. Okay. So it's specifically asking me to find the rate of change for day 1 and 2. So I only want to look at day 1 and day 2 columns of information. So let's look at change in y. Remember, y is on the bottom. So if I go from 15 to 45, that is a change of positive 30. For day 1 to 2, I mowed 1 lawn on day 1, and then on day 2 I jumped up to 3. So that change is a change of 2. And that means that 30 divided by 2 is 15. So for my first 2 days, my rate of change was 15. Now we're going to do the same thing. Now they're asking us for day 2 to day 3. So we're only concerning ourselves with these 2 sets of data. So from 45 to 90, that is a change of 45. And now for my x values, I started at 3 on day 2, and then I jumped up to 6 lawns on day 3. So that is a change of 3. And 45 divided by 3 is 15. Okay, now I know most of you, this is where you're going to stop, because you're going to see, oh, my rates of change are the same. I know it's constant. Here's the deal. If they're asking you to calculate your rate of change, you want to find it for every value in the table, because if you notice, our change in y's and our change in x's are not the same. So I want to make sure that this last rate of change between day 3 and 4 is also 15. So we're going to keep calculating, and we're not going to stop just yet. So I have a rate of change for y from 90 to 120. That is a change of positive 30. And then for my x values, I started at 6 lawns on day 3 and jumped up to 8 on day 4. So that is a change of 2. And 30 divided by 2 is 15. Now I can confirm that all of my final rates of change are the same. So this would be constant, which tells me that my graph line is going to be a straight line. I just don't know if it's going to be straight going up or if it could be going in the down direction. All right, last example, example number 2. The table shows the approximate height of a football after it is kicked. Tell whether the rates of change are constant or variable. So again, we now have a table. It's vertical like we're used to seeing it. So I know that X is on the left always and Y is on the right. And this makes it really easy for me to determine my input and output values. X is time, and in this case we are measuring time in seconds. And Y, the output, is height, and we are measuring the height in feet. So I know what my quantities are. And now I can find the rates of change. So change in Y over change in X. Change in Y over change in X. I'm only going to write 2 right now. We'll see if we need to add a third because we do have several rows of data here. All right, for X, from 0 to half a second, that is going to be a change of positive 0.5. And for my change in Y, at first, it is going to be a change of 18. So let me go ahead and put my change in Y, 18 over my change in X, which is positive 0.5. And now I'm going to perform that division. 18 divided by a half is going to be 36, and you need to check your mental math on your calculator, because if you had 18 candy bars lined up here and you divided each candy bar in half, how many pieces would you have? Well, there are 2 halves in one candy bar, and I have 18 of them, so 18 times 2 is how you got 36. It is not 9. All right, next change in Y over change in X, so let's do Y first since that's what we're really supposed to calculate. 18 to 31, so that is a change of 13. And then change in X, I go from 0.5 to 1.5, so that is a change in 1. And I can clearly see that 13 divided by 1 is going to be a rate of change of 13. Now, because my rates of change are already different, I did not get the same final rate of change for both ratios. So I can stop here. I now can say that my rate of change is going to be variable. It is not going to be constant, which means I am going to have a curved graph line. There is going to be some curve in my graph at some point. It will not be entirely straight and constant like a linear function. I'm not going to bother finding my last rate of change in the table because I can already see it's going to be variable. It is not going to be the same. And hopefully now you understand rate of change and are ready for SLIP.